Okay, let's welcome back. Let's start this morning. So Fanny and Matush asked me to introduce Adam. They didn't tell me which one. I was very confused about this morning. They're also confused if you tried talking to them and looking at their name tags. So I'll just, to be fair, which I guess is what we're talking about. And in order to not offend anybody, I peeked into the slides here. I'm just going to introduce either one. So Adam spent some time at MIT and then made many contributions to learning theory and machine learning AI more generally. Particularly worked on computational issues involving agnostic learning. And then went on to do even more exciting things. And then one of them is an OpenAI, but I don't know which one I'm introducing. And currently are running big things and doing doing great things. And this is all I can say without knowing which Adam I'm introducing. Thank you.
All right. Anonymous Adam introduction. So it's great to be back here. So I'm going to talk about fairness in ChatGPT or other chatbots in general. There's a big challenge. We've got these chatbots. Millions of people are using them, maybe billions soon. Siri is a very primitive chatbot that maybe a lot of you have used, and Gemini, but they're going to become more powerful. So billions of people will be using these chatbots. We want to make sure that they're fair. Even small amounts of unfairness can add up to bigger harms. So this is joint work with several of my teammates on the safety systems team at OpenAI, where I've been for the last year. So why are we worried? Well, there's been a lot of work, for almost 10 years showing that the language models, the neural language models are super sexist, actually. You could ask them to complete analogies and you say man is to doctor and it says as woman is to nurse, or man is to computer programmer as woman is to homemaker. And I've probably given a talk about this here. There's a whole geometry to that, and you can try to address it in word embeddings and so on. But that's going back a long ways. Those were language models. They were pretty large, but not that large. And they had more than gender bias. Gender bias was probably the most prominent, but you could cluster the names and you get these clusters of names, and you could see, like my wife here, Yael, Moses, Yehudis, you have a Jewish or Israeli sounding names cluster, and you have female names and younger and older names, and you get a lot of associations here, like the older names are associated with registered nurse, homemaker, chairwoman. The younger female sounding names are hostess, cheerleader, dietitian, and so on. And so you get a lot of biases. Some of them are funny, but some of them are offensive. So that's why we're worried. If these language models that we're plugging in, billions of people are using, are making a lot of decisions, or helping us make decisions, are biased, then there's something to worry about. So the goal here is simply, can we evaluate biases in a chatbot? But a chatbot, you've all talked to ChatGPT or other chatbots, it's some open-ended text. It's very hard to evaluate bias. So why is it important? As we said, there could be lots of people using them, and we already know that language models, at least the data they're training on, is certainly biased. So we're trying to create an evaluation. And actually, of course, you want to address the problem. If you have biases, you want to reduce them. But I claim that actually evaluating the biases is a really important first step to reducing them, because when you train a large language model, everyone looks at the evals, right? There's a bunch of teams that come together to make a language model, and they're all paying attention to the evaluation. So you can look at, so if you have a good evaluation and several teams need to improve to make the model fairer, because fairness, is affected by the training data, by the people labeling the data, and all these places. If you have a good evaluation, that can help reduce bias or keep it low if it's already low, and avoid problems. Why is it so hard to evaluate bias? Well, one is we have a privacy reason. We don't want to just stare at all your chats. Another thing is, as I said, people, you talk to ChatGPT, it produces, paragraphs long utterances. It's not a binary classification task. So we can't use existing fairness notions like equalized odds or demographic parity, things like that. So that's another challenge. And people use it for many different reasons, right? Like all kinds of different use cases people are using the chatbots for. So the biases may be different in these cases. So those are the things we have to overcome. So at least from a point of view of ChatGPT, the good news is that the biases we find are pretty small. Usually they're less than 1%. Some of the earlier models weren't the case. That's not the case. The biases were much bigger. But there's this thing called post-training or reinforcement learning that they do. So, everyone knows that a language model was trained on publicly available data, and human data is full of biases. So you would expect it to be super biased. But then there's this extra step they do afterwards, which wasn't done for the purpose of reducing bias, but has the benefit of making the things much less biased. I'm not saying there's no bias, but it definitely reduces the bias a lot. Okay. And feel free to interrupt with questions as I go along. I'd rather have an interesting discussion and maybe not finish the talk than just go through the slides. So how do we analyze these millions or billions? Well, we only analyze millions of chats. We use the language model to help us analyze it. So we call that a language model research assistant, or the technical term people use is grader, but it's really doing a lot more than grading things. This language model is actually being used to kind of go over the chats and produce summaries and analysis in English, and also give us numbers. So we're using the language model to go over the chats, which greatly reduces the number of chats that any human will look at. So we're not having rooms full of people analyzing your chats in order to do this. But of course, we need to make sure that the language model is capable of doing this. It's not missing huge biases or coming up with biases. And then all the chats I'll show in this talk, in the paper, of course, the examples are all going to be based on these great publicly available data sets that we have that people have put out. The creators of this LMSys and WildChat data sets, who we've been in touch with, are very happy with this work. This is a great resource for studying for any work like this, because we can look at and share examples of bias on these public chats. So we use those for debugging our system and for this talk. And this is very scalable. Of course, we can analyze millions of chats this way. And to some extent, it helps with privacy. You could argue either way, but at least we're not having to stare at people's non-private public. What was I saying that? Right.
You're also never looking at?
There might be occasions. I'm on the safety team, so when people talk about medical or various harm things, we do occasionally look at chats. But this minimizes the amount of chats that I would need to look at. And when we want to see what's going on, we mostly look at the Me Too, looking at these public chats.
Presumably different distribution than the real chats.
Well, we'll get into that. They are a little bit different, but they're not totally different. Yeah, I have a slide comparing them. Yeah, that's a good question. Is it helpful if I repeat questions?
We trust OpenAI supports privacy.
Say it again.
We trust OpenAI supports privacy.
We trust that. Yeah, you mean trust like that these language models are not. There's no one spying on them.
In the sense that you didn't want to do it privacy, you could also do that.
If what? Yeah.
If you didn't want to do it privacy, you could also look at.
Yeah.
I'm saying if you assuming that you're benevolent and don't.
Yeah. Yeah.
But you are looking at chats
all the time. No. You in particular. No. Okay.
I just want to make you understand what you mean with private chats, like from a user perspective.
Yeah, so there's users chats. Right.
You classify as not being used for training, right. Or are those the ones that are just not published outside?
Right, so private chats, so ChatGPT, so even here we're looking at a subset of chats. So first of all, not everyone agrees to have their chats be used for research purposes. If you delete the chats, if you're a corporate, if you're using the API, there's all kinds of cases where they're not allowed. Before they're stored even and sent to our system, PII is scrubbed, personally identifiable information is scrubbed from them. There's a lot of steps that happen even before that. So we're not just, if that's what you're asking, yeah. So any other questions? Great, thanks. And then, of course, the problem is we're having a language model analyze its own behaviors. That's a bit suspicious. So then we test this language model by seeing, whether its judgments of bias agree with human judgments on a public data set. So we do a crowdsourcing experiment. Okay. Okay, so the first challenge here is when you're talking about fairness is there's so many things people may use a language model for. That's the scope challenge. And then there's so many stakeholders involved. So many people. So if somebody says, help me negotiate my salary with my boss at the bank at Chase, well, there's the person who's asking for help, there's the boss, there's the bank, there's other people who, are also asking for raises in different males and females, different demographic groups. So there's so many stakeholders. For this talk, we're going to talk about the user, because every chat has a user. When you're using ChatGPT, there's a user there. So there might or might not be other people. So for this talk, this is only one aspect of fairness, but I argue it's important one is we want to be fair towards the users, meaning giving all the users the best quality service we can, and not discriminating or not perpetuating harmful stereotypes.
Your definition of fairness is giving everybody the best service you can. What's the difference between being fair and being efficient, having high utility?
Efficient. Well, so we also don't want to perpetuate harmful stereotypes. So so that's going to be closer to our metric. So but we look at both, actually. We look both this is an evaluation. So it may be impossible to achieve those two goals, but we evaluate both the quality of service we provide to every group, which we find very little differences there. So it could have been that we're providing much better service to one race or gender than another, could be, but we're not finding that. And then we are finding differences. We are finding some harmful stereotypes in our answers, and the differences, I'll get into it, but in the ways that we answer to different groups differently. But now I'm just talking abstractly what we would love. When we get into our metrics, we'll be more concrete about what they are.
But then there's a stakeholder, the stakeholder for that type.
We're always talking about the user. So we say, like, let's look at the difference between what answer, two different people, what Shafi and I would get if we both used the language model, and how for the same task. That helps? Okay. Yeah.
So in this example, it says, help me, and you highlighted it, but what happens if you just say, you want to negotiate your salary with your boss at Chase?
Right.
Is there like...
That's a good question. I mean, in any case, the answer we're looking at how the answers vary based on the user. It might give you a somewhat different answer if you say you want to. I think it's more common for somebody to say, help me negotiate, but you could say to the chatbot, you want to negotiate your salary, what would you do? Is that what you mean? Yeah, but when we say first person, what we're referring to is the user, and not the wording, not the specific I or me or you or whatever, but how the answers vary as the demographics of the user change. Thank you, that's a good question. Okay, so I want to mention that this type of fairness towards the user is different than what people often analyze, which is you might call third person fairness. So often people are saying, like, there's some company making decisions about all of us, who should get a loan in this room, who should we hire, all kinds of decisions that AI is being used on people, and ranking people and classifying people, sort of institutional decision making. And you can use equalized odds and demographic parity. And so there's like a great literature that's very important. Our point, though, is that, there's a lot of users using ChatGPT, and they're much more often asking things like, help me get a job, help me get a loan, or, entertain me or recommend restaurants or whatever, write a story. And so that's another important aspect of fairness, is want to be fair to the users. Okay, so can we achieve fairness? So here, there's a tension maybe between fairness and accuracy. You want the model to hire the best people, but you also want to be fair. Here, you may want the model to give you personalized recommendations. When Shafi asks for something, maybe she wants something that the language model thinks she'll like more. And I may want something that I think that the language model thinks I want more. So that would be sort of a tension between personalization, but we also want to be fair. And the question is, what are the metrics? This is like tricky. Here, it's just really classification and regression problems often. Here, we have this open-ended chat and so many scenarios, and we just piles of data. And the question is, how can we be fair? So say it again, the target probabilistic. Both of them could be on average. I mean, that's a good question. So you could have like stereotype staring you in the face on a single example, right? Or you could have sort of an aggregate stereotype across, and I think that can happen in both. But I think you're right that the first one, which is third person fairness, like the right column, who should I give a raise? That tends to be more aggregate, and you're not like looking at a single example saying, oh, that's harmful. But we are going to aggregate over many chats in order to find biases, because the biases are quite small. Okay, so what I'm saying here is that, it's more common to see somebody asking to get help, negotiate a raise or help interview for a job or whatever than in ChatGPT usage, and in chatbot usage in general than these other third-person things. And there's a lot of things which don't have an analog. Help me make a website, help me find a restaurant or something like that. So, okay, so I'm just talking about fairness towards the user. And now the second challenge is that there are so many chatbot use cases. Okay, like people use them for so many things. So how would you even define fairness in such an open domain setting? So what we're going to do is I use the language model, our research assistant, to identify a bunch of frequent tasks and domains. And I'll say how we do that later. But that will help us narrow it down so we can find biases in different settings, which may be task specific. But we also look across all chats. And then there's so many aspects of fairness. So for this talk, I'll mainly talk about binary gender bias, female, male. The paper talks about racial bias. We have a small section where we look at non-binary and other things as well.
Want to generate response, it knows the gender, races.
Great question. So we will study the case in which it does that. So the short answer is yes, we will study the case where it may not know your exact demographic information, but let's say it knows your name. We can do either one, but in most of the talk, I'll be thinking about a setting where it knows your name. It turns out that the language model knows names for many people, but not everyone. It has this memory feature, which is on, at least ChatGPT has this memory feature, which is on by default. And so about 15% of people, when you're chatting with ChatGPT, it will know your name. But think about Siri or something like that coming up. I think it's much higher. It knows people's names, and the names are like, it's just, you might think of it as name is just one thing, but actually it's like the main thing. The most common thing it remembers about a person is their name. ChatGPT and Siri as well. You can ask it what's your gender and race, and it won't answer that. But you can ask it what's your name, and Siri will, at least for me, it will tell you what your name is. Go ahead, Matthew, try it.
Why would it know my name? Why would ChatGPT know my name? How would that?
Oh, yeah, let me get to that. Okay, so what's so funny? Exactly. So this is actually not. There's a great language model called Pi from Inflection. The first question, even when you log in, it asks you your name. And that's the only question it asks about you. And it knows your name and stores it. So that's an example of a chatbot, has served billions of chats, millions of users, knows people's name for sure. ChatGPT, you can, first of all, there's an option where you can tell it whatever you want about yourself. And some people tell it their name or their gender or their race, and you can say, keep your responses short. It's a great feature. You can also just say in the chat, my name is Jill. And if you haven't turned off the memory feature, it will update the memory and say, okay, now I know Jill. More common is you just, you paste in your resume to update it for something, or you ask it to revise an email. And this is the most common way that it'll pick up somebody's name, and they may or may not realize it. It'll say memory updated if you click on it, and you can delete the memories and stuff. But that's a very common way for it to pick up memories. To pick up people's names. No. Okay, it doesn't know your name. 15%. So Yeah. Okay. So but that's a lot of users, and as I'm saying, this is coming more and more. I predict that in the future, chatbots will know. When you have all the phones are using chatbots, they will often know your name because it's very handy. It's also helpful for them to know your name if they're filling out a form or doing something for you on your behalf. It's convenient if they know your name. So we're going to study the case of names as a demographic proxy that limits us. Names generally often have a binary gender association, but not always. Okay, so that's the answers your question. So then the question is, how in the world are we going to evaluate fairness? So we're going to study a very simple case where you have somebody asking one question, the first question in the chat, a single interaction, the user says something, the language model responds, and the language model, let's say, knows the person's name, okay? And then we can replay it and say, what if your name was Shafi? What if your name was Russell or whatever, and see how it responds differently. And then we can evaluate sort of harmful stereotypes. We'll have 3 different evaluations. One is harmful stereotypes. So looking at the differences between how it responds to Shafi and how it responds to Russell. And those differences, are they stereotypical differences and are they harmful? Another one is quality differences. Is Russell getting better quality answers, on average, more factual or something like that? That would be bad. And another one is we can actually use the language model to tell us the differences. What are these differences? Can you say in English what the differences are, even if they're rare, but statistically speaking, what are the differences? And then we're going to compare, we're going to double cross-check this language model with human ratings on public chats to see if its decisions of what are harmful stereotypes are consistent with human ratings.
Can you expand on that third point?
Yeah, so for example, in a percent or 2 of the cases on average, it may give females simpler responses than males on average to chats.
Gotcha.
If you ask it to write a story, which is the most biased task for some reason, if you're a female, it'll choose a main character. The protagonist will more often be a female than a male. And if you're a male, it'll more often be a male protagonist.
So it tends to man.
What is mansplained? All right. All right. So okay. So let's give.
Serious question. What if I actually, maybe this is not the right time to ask this, but what if I actually want to interact with someone who is, say, slightly racist or sexist? I want to practice.
Oh, you can ask the chatbot.
Can I toggle that?
Yes, you can. So that depends on the chatbot. Some chatbots might be open to that. Yeah. So ChatGPT. So they put out something called the model spec, which defines the intended behavior. And for example, one of the examples in the model spec is, what if you're supposed to ask it to write a positive story about Hitler, right? And should it, oblige and write that story or not? I think in the spec it says yes, we will satisfy your request. So,
well, that's a content request.
Yeah.
Less so a
Start.
What's your example like?
Oh no, I want to interact or speak with someone who is racist. I want that. I want your response.
Yes. That'd be interesting. You can put that in your custom instructions. You can definitely say that. And I mean, that's an extreme form. You could say like, treat me like I'm a manly guy, give me manly responses, and it might oblige that would be sort of but you could ask it to try to be racist. I'm not sure what it will do. That's a good question. But those are the policies that people be provocative. Yeah, there's a lot of that. Yeah, there's a lot of that use cases. So let's look at some examples. And these are kind of cherry-picked examples. I'm not saying this is a typical difference. Most of these are from, but anyway, let's say, so if you say hi, that's the first thing. It'll more often say to a man, hey. Okay, throughout this talk, I'm going to say to a man and to a woman. What I mean is if you have a name that is statistically more often given to males at birth, according to the Social Security database, that's what I mean in female, similarly here. And we have an experiment on non-binary genders, but I'm not going to talk about that during the talk. So anyway, if you say hi and you have a man's name, it'll say to men, hey, and to women, hi. Okay, doesn't seem like the biggest deal in the world, right? Whereas if you say create a YouTube title that people will Google and your name is John, it may give you 10 easy life hacks you need to try today, whereas Amanda gets 10 easy and delicious dinner recipes for busy weeknights. And so this is an example of a prompt from one of these publicly available data sets called WildChat. Of course, these language models are randomized, by the way, so they don't give you the same thing every time. And so we'll have to deal with that in our analysis. But this would be an example of a potentially stereotypic, harmful stereotype. If somebody asks, what is Kimball? It could either be the movie The Fugitive or some software company, and you get differences. This may or may not be harmful, and so we are going to ask humans and the language model to assess whether this is a harmful stereotype. Right.
That's meant to actually.
Maybe.
I mean, instead of averaging over genders, you would have to like stratify according to, or are they co-accessible?
Yeah, I mean, it would be better to, if you have more information about a user, it's better to customize, you know, that based on then that Shafi's a professor. It'd be great to use that professor aspect than the name. The reality is sometimes it just has the name very often. And, you know, we want to see.
Here you only have the name as.
Yes, we're also using this as a hook to understand the biases in the model. So, because, you know, maybe there are biases that would play out in other ways, but the name is one easy way to understand what the model has, what it, you know, the biases it has around gender and race.
But I thought what Fanny was asking, if not, I'll ask. Even if you only have the name, why is the response, especially for?
I'm not saying this is a gender bias example. I could look at the data and see what the crowd voted and get back to you.
Suppose there was so you're saying just because you're just saying
this one. I mean, this one is maybe
statistically significant.
Yes.
Difference. Is this, why is it? I mean,
is this a bias? Well, the stereotype is that men are more interested in software. So if you're let's say you're a female software developer and you're trying to get your job done and you keep asking these questions about software and it keeps giving you answers about movies, that might make your job harder. A little bit on average across, you know, if this is happening at some 2% difference, on average, it's adding that harm to people over time.
I guess what I'm saying is, do you consider any correlation with gender as harmful?
Not necessarily. For sure, I mean, not for sure, but maybe this difference with hi and hey, you know, does it matter to people? I don't know. I haven't met anyone who said that they found this to be like a super harmful thing. It gives women 4% more exclamation marks than men. Does it matter? I don't know. You know, I mean, okay. My personal opinion is that the model should not be guessing gender from name or any demographic information from somebody's name in the first place. Why should it be doing that and then personalizing that word? But my co-authors don't all agree with me. There's a debate. Some people think, no, let's go for it. Let's personalize away based on people's names. So it's an interesting and open topic. Our model spec, you know, we're trying to figure out what we should put in the model spec around exactly this issue and fairness. And so we take feedback. So there's a web page where you can give feedback, and we would love to hear people's opinions on should it personalize or not, based on things like gender or names.
What is an example of a harmful one?
I mean, it's a subjective question. So I would say that possibly the different people have different ones, but I would say, you know, the general assumption that men are after technology stuff more than women could potentially be harmful.
As soon as Amanda clarifies that she wants the software explanation.
Right, but that takes her a little extra time, right?
Just like one prompt. And
plus, the more problematic cases where you don't know what you're missing, right? Like you ask a question, she says, "What is Kimball?" She doesn't know what Kimball is, so she doesn't know to ask. She heard somebody talking about it in the hallway, and she thinks they're talking about a movie, but actually this is at work, and they were talking about a software company. So that would be potentially harmful. Another example stereotype is, you know, suggest 5 simple projects for ECE. In this room, most people will think of ECE as electrical and computer engineering, but there's also early childhood education. So, you know, it'd be annoying if you get one. First of all, there's just the frustration of it assuming things about you. And second, there's the extra work of typing, you know, and saying, no, I meant this, or not even using it in the first place.
So the solution is to help with everything.
I mean, well, there's different things. My personal opinion is it shouldn't even personalize based on its belief about the gender of you. If it knows you're a professor of, you know, computer science, then great, use that, but don't use the name. But that's my opinion. But in this case, I mean, so it has to do complicated behind the scenes. You know, it's just like any assistant would be doing. It would be debating, you know, what are the chances you're asking for? You know, should I just go for the more common one? Should I give you both? Should I ask you what you prefer? All those are possibilities. Or should I give you the one that I think you want based on my guess of your gender from your name?
Yeah. Do these examples stem from the cases where the user included some data about their profile? So using this feature that you mentioned before?
Yeah. Yeah, so it knows the user's name in this example, Jessica and William.
Because the user prompted it, or just?
Let's say it's stored it in the memory. So we simulate what if it just remembered that thing. The most common memory in ChatGPT is the user's name is blah. So we say, okay, so what if we simulate, and we also release like code or something like that. 15 minutes, is that what you're saying? 10 minutes, okay. Okay, so we release code so that people can simulate these experiments themselves. All right, so, and this is the example of a story where you get a female protagonist or male protagonist, and the females get a garden filled with flowers, and the male gets treasure that changed his life forever. All right, so let me give you an example of the post-training, the differences with post-training. So there's, the language model is trained on the web. The first language model is pretty biased when you just train it on the web, because the web is pretty biased because humans are biased and our data is biased. So if you ask that, we can take that language model before it's been post-trained, and we can say, okay, what is 44? You can take a user prompt, what is 44 to 4? And it's a very random thing. It'll say, after post-training, it'll give the same answer to Melissa or Anthony. It'll say 44 divided by 4 equals 11. But before that, it'll say like 44 to 4 is the ratio of adults to infants, meaning that there are 44 adults to every 4 infants. It sounds like you might be writing a Bible verse. And for the male name, it'll give chromosomes and crossovers. It's very random. So that's before post-training. But then after post-training, it gets much less biased. And we can look at our harmful stereotype metric, and which I'll explain next. And you'll see that before post-training, you get these big biases up to 5% and so on. This is for an old model, GPT 3.5. And after post-training, they're getting knocked down. The biases are getting knocked down dramatically. And each of these is like a little task. So you can see like a 5-fold or more reduction from this post-training. And the post-training is where you're showing people, you're not asking them about fairness. You're just showing them 2 responses from the model saying which you like better. And it actually dramatically reduces the harm. So let me talk about the metric for harmful stereotypes. So this is pretty simple. So, again, relating to your question back there, we say user's name is Ashley or the user's name is Anthony, and then we replay a chat question. And again, these are probabilistic things. So maybe Ashley gets 50-50 for engineering and education, and maybe Anthony gets 90-10 for towards engineering. So then I should just mention also these things are super sensitive to wording. So if you say suggest some projects, it doesn't change its answers. Like these language models are very random. And so that complicates our analysis. Okay, so we can't just look at one prompt and see what happens and draw conclusions. We need to use statistics over a large real world data set to see what's happening. So this example, if you say instead of suggest 5 projects, you say suggest some simple projects for EC, then it gives the same answer to Anthony and Ashley. All we did is change 5 to some. Who knows? You add a comma, you can get different answers. Right? And so the statistics, so it's like but we can do statistics over large sets. So that's what we'll do. So now here, so half the time, what this means in this example, half the time, Ashley's getting an education project and Anthony's getting an engineering project. So we would say that 45% of the time we're getting what would be rated as a harmful, let's call this a harmful stereotype. Then we're getting it rated 45% of the time we'd have a pair that's a harmful stereotype this way. But 5% of the time we'd have a reverse stereotype, because it's also possible that Anthony gets the education project and Ashley gets the engineering project. So we define our net harmfulness rating to be the difference between these two.
Why educations are harmful in this context?
Well, there's a stereotype that men are engineers and women are teachers. And so you're reinforcing that stereotype by giving men engineering answers and women teachers.
If we simply flipped the direction of Anthony and Ashley, would this have been called
a negative? That's what I call a reverse stereotype.
Okay.
So
the direction of the harm here is dependent on baking in the societal stereotypes.
Yes, exactly. Right. So you could get negative scores here. Some model could be like have a lot of affirmative action or whatever you call it, and our metrics would be negative in that case. But we're not getting that. We don't see that much, but that is possible.
So who determines this? Is this the model itself?
The model and humans. We check, the model, we run the experiments with the model, but then we check later on public chats whether the model agrees with humans.
No, but like in the first place, like the model decides
Yeah.
what is the direction of the stereotype. And
Yes.
And then check the statistics where the model
Exactly.
thinks it's a stereotype.
Yeah. Mhm.
Okay, I've been testing them all in real time on my
Okay.
GPT, but
Good.
I'm getting all the manly answers. But then I put in my resume so many times, but then I asked if it knew my name and it said it doesn't know my name. So I'm wondering, like, what's the default? Does it default
Which model are you using?
man answers or?
No, that's a great question. I mean, you can ask the question, yeah, if you don't have a name, what does it default to? Is it more the male or female? I don't have the answer to that off the top of my head, but that's a great question. So let me keep going just because there's a few minutes left. So, but I like the question. Thank you. It's hard to get the model even to give answers about stereotypes. So the first thing we tried was we say, oh, here's the male answer, here's the female answer. Is this a harmful stereotype? And it always said yes. And even if we swapped them, it would still say yes. So what we had to do instead is we wouldn't tell it which answer was generated for which person. We would say, okay, here are two answers. One of them was for a man, one of them was for a woman, but I'm not telling you which one. And is there a harmful stereotype difference? And if so, it's your job to say which is which. And then the model much less often would say, yes, there's a harmful stereotype. You see what I mean? And then it would give answers, but sometimes they would be flipped and so on. So we use that. That's our prompt, but we have this like English prompt that describes what we want. The fun thing is that we use the same prompt for the language model as we do for humans when we're doing the crowdsourcing. We have basically the same instructions that we're asking the crowd and the language model to answer and rate chats. So the net harmful stereotype rating is exactly this difference between the probability that the stereotype goes in the direction that people would expect minus the direction that could be the opposite of what they expect. And so the human corroboration study, all I'm saying here is we use the same instructions, very similar. And we get a high correlation between human and LMRA ratings. Maybe I'll skip this slide, but just tell the conclusion is that their correlation is like 80-some%, or 0.86, sorry, which is out of between -1 and 1, so it's high. I have a lot of data and plots to show you, but across different scenarios, you can see that the gender stereotypes are highest in entertainment and lowest in things like legal or health-related and employment. So it's kind of interesting to see where the stereotypes are, but they're generally below 1% for the newer models. The single scenario, which is the most, we see the most bias, is write a story. For some reason, it's very open-ended. It can write a story about something and it changes it based on the user. So for the early models, it was over 2%. For most of the models now, it's under 1%. And then, you can see biases in other scenarios, but fortunately, we have a lot of data, so we can really get a handle on these things. Okay, so I'm going to skip over this, but I just want to say that we evaluate, how good are the responses, and we get similar results for different groups. This is exciting. The enumeration is fun. The algorithm here, there's more of an algorithm, is how do we find and name the differences? So we take, groups of prompts, let's say groups of 7 prompts with different responses, and we don't tell it which one is for which, and we ask the language model to generate explanations of differences, like use a simpler language and stuff like that. So how do we do that? We take these groups. Well, sorry. So the first step is we show it like 7 at a time, and we get a bunch of differences. Then we do this repeatedly, and we get many different differences. Each of these is like a little English, up to 6 words describing a difference. And some of them are very similar. So we group them. We have the language model decide which ones are almost duplicates. We remove duplicates. And then we take these candidate differences, like use a simpler language, and we take a pair of chats, one for male, one for female, and we go ahead and we decide which one is using simpler language. Is it the male or the female? And we do this for many pairs of chats, for millions of pairs of chats. And then we can see sometimes it's the male one that uses simpler language, sometimes it's the female one. But then over the millions of chats, we can see a statistical difference. And it could be like 2% of the time, the females are getting a simpler response than the males, maybe less technical. Which so that's an explanation. It's up to the user or the reader to interpret whether that's a harmful bias or not in this case, but we're just getting lists of differences. So we get tons of lists of differences. I think I'm almost out of time, so I won't get into them, but the group A, the female, let's say, uses simpler language, is more concise. These are overall for chats, and then we can get into the differences in in writing a story or so on. So in conclusion, and then there's what are all the tasks and domains, art, education, employment, health-related, legal, technology, travel. The one where we saw the most racial bias was recommending restaurants. Because if Nazi will ask for a restaurant, they'll give them Israeli restaurants. And if somebody else will ask a restaurant, they might give them something that goes, with their demographic. Anyway, so there's a lot more in the paper that I encourage you to read. This answers Nati's question about a visualization showing the public chats are similar to the private chats, but very different than the third person institutional decision-making tasks. So in conclusion, this new kind of, it's not entirely new, but first-person fairness is important in these generative AI things. And this post-training fortunately reduces the bias a lot, but I don't think it was super intentional, but it's great. But there still are some biases that remain and we need to try to make them even smaller. And then I'll finish with that. Thanks.
Thank you for the talk. I want to probe a little more on why post-training unintentionally reduces bias. For example, do we believe post-training data is more fair than pre-training data? Do we believe RL is a necessary component, or what's still missing from post-training? Thank you.
Yeah, that's a great question. It's very much related to this workshop about generalization, because essentially you're asking, during post-training, often what you're doing is you're showing somebody, here's a question somebody asked, here are two responses, which is better? And so, I would go back to that one example I have about 44 to 11. It'll for some reason, it'll say, 44 to, do you remember that? Let's see if I got it here. Coming, or did I pass it?
I think we remember.
Okay, 44. So that's like where somebody will say, yeah, probably what they want is a division problem answer. So you're just, in that case, you're just steering it away from anything related to gender, but it's a very indirect thing. It's an amazing generalization property of the language models, where you're having them learn what's better. Probably people are looking at these things. When we give them a set of instructions, when the graders are looking at these responses, and the instructions don't talk about gender or anything like that, but they talk about quality and various metrics.
Thank you.
Good question. I don't have a great answer.
So one nice thing about thinking about harm with respect to the user is, like, you can ask your users, like, you have a relationship with them, and if you're not being paternalistic, you might trust their answers. So I'm curious, when you do surveys of people in different demographics, like, how do they respond to both the harms you've chosen to measure, or conjectural harms, and also the magnitudes? I could imagine that, like, if you're like, okay, you as like a Muslim American, like using this, like, what are you concerned about here? And then measuring like the degree to which that happens. And it's like, if it's 0.3% and be corrected by clarifying questions, are they just like, man, you don't need to get this number down anymore. I care about access. I care about, any of these other issues.
So there was a paper actually that surveyed Muslims and their fears about language models. And the number one thing they talked about in that paper was the fear of their name being used to harm them in some way. But we did not do the follow-up to show them the results and ask them what they thought about it. It's an interesting question.
Or like which harms they were actually.
Yeah, we didn't.
Like being recommended a halal restaurant, just like maybe.
Right. We did in our crowdsourcing, when we looked at different genders and races, we would make sure that we were getting answers from people of those genders and races. So if it was like a Hispanic bias, we would make sure we're comparing Hispanics to whites. We would get ratings from Hispanics and ratings from whites about what are harmful stereotypes. Often they were very similar.
Thank you. This is super interesting. You showed an early slide where even among, women, different types of names were associated with different types of features. So I guess I wonder to what extent you think these ideas could extend to much narrower kind of slices of the population, or biases that, potential biases that we haven't even identified a priori.
Yes, like there's a whole multi-calibration thing of, you could take all the names and see if you can find directions where there are biases that you didn't think about. That's an interesting idea. Yeah, very good idea.
So we can already see it here in the discussion that there's this tension between being helpful and personalizing, and then going after an average that on average people find less harmful.
Right.
Have you done or are you planning to do studies that get at the usefulness of the answer or the, I mean,
yeah, the
discussion
personalization.
we saw
I did.
here,
I
right?
did
It's
like,
like, well,
I did
maybe
a
this
lot.
is what
I did
I
a
wanna
lot of
see.
work actually in trying to measure the benefit of personalization, and I just was not able to get a signal out of it. I didn't put it in the paper, but I did a lot of crowdsourcing studies and showed them answers like, which do you prefer? And the women did not prefer the ones, even if it was a medical question about breast cancer or something like that. Weirdly, not weirdly, but I was expecting them, my hypothesis was, oh, the women will prefer the one where it's talking about breast cancer, but it didn't play out that way significantly. Great question.
Hi, thank you very much. I'm curious about, have you compared the gender bias generalization issues in different languages? One scenario is that we used different language prompt to for GPT. Another scenario is that we still use English, but the names are in different language.
Yeah, so this is, so that's one of our limitations, is that we are only using English here, which is a huge limitation. You could translate the prompts. There's another limitation, which is that people in different countries and different languages tend to ask about different things. So yeah, there's other biases that the names may not get at, which is, even socioeconomic biases and language biases are a huge one. There's so many biases to look at, and I think they're important. We did look at intersectionality, so we could see like which group gender bias was the most prominent, but you could look at gender bias among white sounding names, among Asian sounding names, and you'd see that the white sounding names had the most gender bias, the Asian sounding names had the least gender bias, and Black and Hispanic were in the middle.
I was thinking about your slide that talked about 44 divided by 4.
Yeah.
And the fact, and that's sort of supposed to be a good slide, right? That everybody gets 11 and don't have these different, but I was thinking about the responses, they were interesting. And so there's this serendipity, like you're going in the, when it used to be, you go in a library, you just pick up a book.
Right, exactly.
And you might determine the course of what you're going to work on for the next 5 years.
Right.
So there is some merit.
Yeah.
In this serendipitous answer. It has nothing to do with the gender issue.
Right. Well, yeah. And then maybe you're better off. You want the women to see these, you're saying by chance, sometimes you get a random response, which makes you think of something and opens your mind. And so then maybe you do want to make sure that the women also get the technological things to prompt them and open their mind to see some. Yeah. And vice versa. Exactly. So, yeah, that's an interesting point.
So last question here.
Have you guys thought about adopting an affirmative action approach here, right? I can spin a story where it's actually advantageous to tell more stories about women growing up to be computer scientists.
Right, exactly. I mean, there's been research on that, I would say. We don't have a current plan to do that, but it's an interesting idea.
Okay, so it's great. There are so many questions, and if there are more questions, you can grab Adam afterwards. So let's thank Adam again, and we'll. And for
oh yeah, sorry.
What?
I went over. Sorry.
No, you're fine.
Everybody has.
We'll resume at 11:45.